Welcome everybody to the October edition of IndyPy. I can't believe it's 2022 coming toward the end. Speaking of the end of the year, don't forget we have the Indie Hackers Holiday Party. I don't think they've actually announced the date or anything, but you can kind of plan on first Saturday in December. And I believe it's going to be in person. You can probably not quote me on that, but my intel tells me there may be an in-person event happening. Look for more information coming over the course of the next month. My guess is they won't announce anything until November, but it's always fun to hang out there. And it's a good time to get together with all the indie hackers here in the Indy area. We're celebrating and have been all year, 15 years of being a meetup here in central Indiana. We're kind of more of a global show these days, which is really fun. I really enjoy participating in the global arena with this, but it's been awesome hosting IndyPy for the last 15 years. I want to thank all of you for being a loyal tribe and for your support and attendance. And we look forward to seeing you 15 years from now. Who knows what will happen by then. But we'll continue to gather and hear from great speakers every second Tuesday of the month. And to receive event reminders, make sure you are registered on meetingplace.io as always. And if you're RSVP'd there, you're in the running for the door prizes this evening. If you want to join in and do IndyPy stuff in between our monthly meetings, make sure you join the Slack. We have got an IndyPy organization set up. That bit.ly link right there will get you an invite directly into the IndyPy Slack. It's a great place to ask questions. It's very low traffic. If you've got a burning Python question and you want somebody to help you out on something, definitely join Slack and you can ask. Actually, if you join tonight, rather than using the Zoom chat tonight, please use the Slack chat. That way other folks who are maybe not even in the room could help answer some of your questions. And it'll be a good central place for us to kind of follow up them afterwards as well, because the Zoom chat's kind of ephemeral. And once you have joined or not joined or left, then it's all gone. All right. Follow us on Twitter as usual. If you're going to be live tweeting or want to respond to the live tweeting going on tonight, you can follow the IndyPy Twitter account. Make sure you hashtag IndyPy to share your thoughts as well. But you can definitely want to respond to anything that's going on. We'll be live tweeting the session from start to finish and look forward to any interactions you want to do out there. I want to thank our awesome sponsors. First of all, 6 Feet Up. IndyPy is organized by 6 Feet Up, and we are a company dedicated to making the world a better place by accelerating tech leaders' impact. At 6 Feet Up, our engineers specialize in app development, AI, big data, and cloud technology. Our clients focus on climate action, clean energy, and initiatives that benefit humankind. I'm Calvin Hendricks Parker, and I co-founded 6 Feet Up in 1999, and I've been the CTO ever since. I also want to thank JetBrains for being a really cool sponsor. They've been with us for years now, and so they sponsor one of the door prizes and just support generally things that we do as a community. I want to thank Reify Health and JFrog for being our bronze sponsors. JFrog is also sponsoring one of our door prizes, but Reify Health is looking for developers at all levels. So if you are looking for a new career change, make sure you check out Reify Health. I think reifyhealth.com/careers for more information. And if you want to, oops, went one too far there. If you want to be an awesome sponsor and have me say cool things about you during the meetup that get recorded and played back on YouTube for the long tail of all the thousands of possible viewers who would see this, just hit us up, indypy.org/become a sponsor, or email Laura or myself. Laura's Laura at 6feetup.com. I'm just Calvin at 6feetup.com. We're very easy to find, and we would love to have you as a sponsor. Make sure if you are on our Slack, if you want to talk about career changes, we have a jobs channel on there dedicated to whether you are looking for a job or whether you are hiring. We want to make sure we get our IndyPy community hooked up with people. And the best way to do that is through the closest network of community that you have. And I hope IndyPy ranks in that group. So definitely go on there and post an IndyPy on the jobs channel. Again, there is the same inviter link that'll get you right into the IndyPy Slack. I've said this for probably the last 3 years now, but we have moved to meetingplace.io. You can claim your meetup.com profile over there, and that is the only way you're going to be in the running for our door prizes this evening. So make sure you are RSVP'd over there. You'll have until the end of the speakers session this evening to get RSVP'd, and I'll do the live code random drawing where I will scrape the meetingplace.io stuff right off there live as we were sitting here. So make sure you're RSVP'd by the end of the talk, and then you'll be in the running. All right. All that said, I'm done. It is now going to be passed on to our amazing speaker. We have Srishti with us, who's going to be talking about generating art with using Python and machine learning. And I will stop sharing my screen so that she can get prepared.
Thank you, Kelvin. Thank you, Laura, for having me.
Oh, you're super welcome. By the way, I'll be watching for questions over on Slack and in the chat. Do you want people to kind of interrupt as we go, or do you want to wait till the end?
I'm okay anywhere. I have also set up my Slack and opened up chats everywhere. So if somebody pops up, I'll try to answer as they go.
Great. Yeah. So throw your questions in whenever you have a burning question you would love for Srishti to answer.
Amazing.
I'll let you take it away then.
Thank you, Kelvin. Thank you, Laura, for having me. Hi, everybody. I am Srishti, currently in Vancouver, Canada. So not too far, but in a slightly different time zone. I'll be pulling up my slides, but in the meanwhile, I'm setting up my slides. Can the people who are in the chat let me know that have they heard of any of these terms which I'm going to speak of? Generative adversarial networks, diffusion models, generative art, OpenAI, GPT-3, DALI. If you've heard of any of one of them, just let me know. So I'm just gauging the audience. So from where can I start? Okay, so I'm reading the chat and seems like some of the people have heard about GANs, DALI, some have heard all of them. Some people are comfortable reading the documentation, which is cool. And and Matt has run a modified GAN before. Okay, I myself have not written from scratch. Good to know that we're having a mixed audience. So we'll take it as is. Okay, so I'll begin my presentation. Hi, everybody. Today's talk is on generating art using Python and machine learning. A little bit about myself. So who am I? I'm a machine learning engineer at a company called Cubic Farms in Vancouver, Canada. I specialize in computer vision. So I have worked in various different domains like agriculture technology, earth observation, medical imagery. But one of my hobbies is painting. So this art as a field is close to me. And a shameless plug, I've put some of the arts that I have painted myself at the bottom right. So as I explored this field or learned about a bit of the intersection of ML and art myself, I think this is a very exciting field with many possible applications as they come up in the future. How to follow the slides. This is something I have been started doing very recently. As we go through the slides, we come across various links, websites that I'll talk about, concepts I'll talk about. On every single of those slides, I also have put a QR code. So if you want to follow along, you can just pull up your camera, scan the code, and just see what am I talking about. Since we have a mixed audience here, so my slide is catered mainly to, it's mainly catered for all levels, but there will be few slides which will have slightly more technical details than the rest of them. And those are marked with blue, this blue triangle. So if you're somebody who's very proficient, feel free to take a break, come back after a minute. I promise you won't miss out on anything. If you missed a concept or any particular resource that I have mentioned, you don't have to worry about did I miss a big part of it? Towards the end of the slide, I have put every single website resource link that I talk about in one single page, and it's also on my GitHub. So I'll share it with everybody to take it away by the end of the talk. With this, let's begin. What is generative art? I personally see it as a collaboration between an artist and a computer. It has some sort of mathematical formula, some sort of algorithmic code, which is leading to it. And it is very helpful for untrained people who are not very trained in art, but who still like to lower the time between whatever they want to make, that is the intention, and whatever they think can be the output, that is the realization. The image you see on the right-hand side is an example of a generative art. In the next slide, I'm going to make you question some of your life decisions, because this art was actually sold for £22,000 early this year in an exhibition as a part of the NFT boom. So many of these generative arts exhibitions have started to come up on these generative arts, and one of them was the Phillips exhibition, which you can probably see on the website, and see many other arts which have been sold or are still on auction. But generative art using Python is not something very new. Oh, I think my GIF is not very clearly visible. I'm not sure. But one of the popular, sorry?
It was paying some snowflakes, yeah?
Yeah, it looks like, I thought the code would be visible, but it looks like when I'm sharing, the resolution dampened out. So one of the popular medium of the programming using Python, art using Python, is turtle programming. And I've personally used it for teaching some of the kids. So there's a code, I'll share it later on. A code was written in Python on trinket.io. Trinket.io is a website, and you can see the art it is drawing on the right-hand side. It looks very cool because you can do a bunch of things, some simple to some very complex ones. Processing is probably a term many of you might have already heard, since a lot of them are pretty much a lot into Python in the audience. It is one of those platforms which was made dedicated for visual arts and technology. So some of these examples you see at the bottom are the arts which was generated by the processing, and the many tutorials that people can follow. But this is all about the Python and the processing. Today, we're going to focus more on the machine learning aspect of the generative arts. And the images on the screen is how the progression has evolved. Processing still exists. So it is, the first image is how art was in processing. Second is an art which was generated by a generative adversarial network. We will talk about it a little more in detail later. And the third one is DALL-E. Actually, it's DALL-E 2 to be specific. And you can see the progression or how good and clean they have become over time. Before we jump into all of these specific nuances that we talked about, like GANs and DALL-E and all of the machine learning details, keeping in mind that I might have a mixed audience, I just want to give a very, very rough idea of what machine learning is. I think it is in this way. In traditional programming, we have inputs and we have rules. So we have 2 and 3 as input, and a rule could be plus or addition. So the output is 5. But in machine learning, we have an input. We know the kind of output we want, but the rules is what the machine learning makes on its own. So it thinks about what kind of rule it can make up to generate the kind of output we are expecting. So this is a very, very rough idea of what is machine learning expected to do. So in coming slides, you will see the images and outputs are the images, and the rules are being decided, or rather being made by the algorithms themselves. How was machine learning popularized, or how did machine learning popularize the art culture? So one of the bases came from something called generative adversarial network, or what we very popularly call GANs. What does GAN do? GAN takes some data, some training data. The model will look at it, or the machine learning model or the neural networks. It will look at the data and will try to create some instances of that data that might look like your training data, but might not be similar. And so remember, it is not similar. It's not exactly same, but somewhere very close to it. And because of these small variations, we see different kinds of outputs that might come out of that model. When the very cool website that I usually share with a bunch of my folks is thispersondoesnotexist.com. if you go to the website, every time you reload or refresh the page, you will see a new person come up, and none of those people actually exist in real life. And this was what came out of the GAN models. Now we're going to be a little more technical. Okay, we're saying GANs or generative adversarial network, but what does it mean? Like, how does it work? I'm going to do a bit of annotation, so please bear with me as I switch my screens to explain this. Sorry. The moment I switch, let me know if you can see the other screen. Can you see the other screen? Anybody give me a heads up? Oh, I think I can. Yeah. Okay. Okay. Now I'll give a little bit of, this is where somebody who's expert in GAN just going to grab some water and come back in a minute. You won't miss out. Okay, so how do GAN works? So GANs have two major, usually what happens in machine learning is we have inputs, we have a model, and we expect an output. In GANs in particular, we have, the model has like two subparts. One is called generators, and one is called discriminator. The goal of generator is to generate a fake sample. That was the whole idea of the generator that it always attempts to generate a fake sample. So, fake sample. The discriminator, the goal of the discriminator is to tell that the sample it sees is real or fake. One of the important things to note here is that the discriminator also has access to real samples, because when the discriminator was, the discriminator is a model itself. How was discriminator made in the first place? So we took a model, we took an algorithm, and we showed it a bunch of, say dogs, many dogs. And now a model knows that what a dog looks like. Now we'll show the same discriminator a model of when it was dog, so it now recognizes what dog looks like. Now we show it a model of or an image of a cat. Because the model is so perfect in identifying what a dog looks like, it can definitely say that this is not a dog, or if you make any stupid variation of a dog, if it's not a dog. So by the end of your training of discriminator model, it knows how to distinguish between a particular kind of image. So it knows something that you're sending is real or fake because you already trained on real images. Now, how do GANs work all together? We'll see step by step. In the algorithm, the discriminator has access to real world, the actual real samples, not the fake ones. And it also gets samples from generator, whatever the fake samples are being generated. And now it has a decision to make. Is it real or is it fake? At the first place, it might say, okay, I think it is fake because I already know what real looks like. I have seen enough samples to know what is real, what is fake. So it says, okay, no, it's fake. Now, GAN, what I call, or I think it's probably commonly said, that it's a zero-sum rule. It follows a zero-sum rule. So what it means is one is always a winner and one is always a loser. So whoever is performing badly needs to improve, either discriminator or the generator. In this case, when it saw a fake sample and it was able to identify that, yes, it is fake, it means the generator is not generating good enough samples. So it asks in the model itself, the generator is asked to improve the model to generate even better samples. And this keeps on happening iteratively. So it will generate even better fake samples till the point of time, there will come a point of time when the real sample being sent from the actual real domain and the fake samples coming from the generator, the discriminator is no longer able to identify what is real and what is fake. And that is where we get those beautiful images that we see, which we are not able to identify. Was I able, I tried my best, but are there any questions in GANs? I tried to make it a little more intuitive how GANs work. If there are no questions, I would assume.
I don't see any in the chat, or feel free to unmute if you want to ask a question as well. But this is a really helpful description.
Thank you. So this is how GANs work. We will come back to what issues GANs have, but this is a little technical details. And if you went to grab a cup or coffee or water, you did not miss out on anything. So we'll go to the next thing. Now let's go back to our slides. Sorry, please bear with me as I switch my slides. Okay, now this generates the outputs of these generative adversarial networks led to deepfakes. And at some point of time, this is actually what popularized it. I remember I was back in college when it was starting out. So in 2014, it started. So the first image, I think I did not label it correctly, but the black and white is actually the output of the first GAN paper that came out. The second one, after the various variations have come out between the 6-7 years. The second one, the 2015 is the DC GAN, 2017 is progressive GAN, 2018 is style GAN, 2019 is style GAN 2, and these are all fake images. None of these people actually exist out there. So it basically, over time, learned to make better and better representation of images, and some of these variations of GAN also improved upon the resolution of the images. They vary slightly in how they have been developed, but the basic foundation is still that they're all GANs. Going into a lot of the technicalities will be a little out of the scope of the talk, but if you try to find videos or explanations, many of them are pretty good at how these algorithms work. But as this talk is about generative art, I like to mention that many times when people think about generative modeling or generative art, it is not deepfakes. Deepfakes is a very small subpart. Generative art is a much, much broader term, which is why I say, okay, this led to deepfakes, but we'll continue talking about art. Okay, this was 2014 to 2021. GANs were exploding everywhere. I think major research labs were trying to work on, okay, how can we make things even better, even though they looked so realistic. In 2021, entered Clip by OpenAI. So Clip is a for-profit R&D lab. It was founded by Elon Musk and Sam, I forgot the last name of the person, but Elon is no more a part of OpenAI, but he's still a donor. OpenAI, when it brought Clip in 2021, it brought the idea of, can we add language to the images? So the goal was, can we learn visual concepts from language itself? And what it did was it went and crawled millions of language, or rather text paired images from the internet and trained a new model. The base was not GANs. It had much more finer details of what model they used on. But the beauty of Clip was that now you can using a simple statement, you can identify the objects. So you can see one of the images on the left, on the bottom bottom left, that you show it an image and you give a bunch of texts and it knows which text represents or corresponds to that image, in this case, a guacamole. There are various versions of clip people have made, which you can play around and see how it works. And one of the application was also like object detection. So historically, people have manually been doing finding the objects, what they look like, but with language coming into the picture, now language can help you find the objects pretty quickly. There's a very good video on how clip works. I have given a link of YouTube, but you can also find it towards the end of the references. So it was only time when someone would bring GAN and clip together. They knew GAN makes realistic images. The clip is saying, why can't we make it just using, why can't we also use language to make it? Which led to one of the paper called VQ GAN, and it was basically a language prompted generative art. I'll take a couple of minutes to show what VQ GAN plus clip results look like. And this is important because over time, we'll see how results keep getting better and better as language, using the language and the images. So the code that we will use is by Catherine Crossan. She's an amazing person in the field of generative arts. She's also part of a team called Stability.ai, which we'll talk later. But if you just go on her GitHub, you'll find she has an amazing work on generative arts, and she continues to. So let's see okay, now it's connected. So we've talked about like, we know that we're going to see if we can get art using language, like language prompted ones. And here we're particularly going to talk about VQ GAN. It was one of the modifications of GAN, but used language as a prompt. This code takes a while to run. So I had run it before the talk, so hoping I would not have to run as I do the session, but let's see. The first we'll try to see the results and then come back to it. And since they're running, I can quickly show what's happening. And we will skip out a lot of things, but we only show some things. So for those who might not know, again, this is me being completely naive, assuming there's somebody who's very new in this audience. Google Collab is a platform provided by Google where you can actually do programming on the cloud. It also has like GPU and CPU resources, so it is also helpful for running machine learning algorithms. So if you just Google search Google Collab, you just need a Google account and it gives you a bunch of resources. Excellent. So it doesn't run. Some things will only happen when we're giving talks. Okay, looks like my RAM is not, I have overfilled the RAM, but I still show what I was doing. I was doing it right just an hour ago before this talk. So we have a bunch of libraries, including Clip, which is for what it does is, sorry. So we use Clip to get how the language rates. We have a bunch of libraries. Transformers are another machine learning library, which have made vision and language tuning very efficient. There are a bunch of Python libraries. You can always read them at your convenience. This notebook also gives you an option to choose from a bunch of models, because ImageNet is, for example, one of the oldest and the most popular ones. It has lots of images, which if you train it on, you usually make you can make your model more generalizable. So they have something called Face HQ, which is for faces. Wiki art is for like wiki arts, as they say. Celeb, the last one you see, Celeb AHQ. So it is like Celeb A was actually the original data set of celebrities. HQ is just high quality. So it's one of the high resolution celebrity data sets, which you can use. And I'm assuming one of them is Flickr, the last fourth one. Okay. Interesting. For now, I will skip the code and go exactly to the art part. So the idea was, can we take language, give some prompts and get some art out of it? So this is a prompt that I wrote 30 minutes ago. I wrote a garden with beautiful flowers near sunset. If you are following along and if you have some VQ GAN plus clip open with you, you can give any other prompt that you want. And I'm using the model base I'm using is from ImageNet because I want it. I'm trying to use the biggest data set out there, biggest data set of images. And I wanted to see what it looks like. And it goes through a bunch of iterations. Some of the first ones won't be like as good because it's really a bunch of noise. So you can see it is still trying to create something. But so there's no sunset right now. It is a bunch of colors and bunch of flowers and trees. But over time, it tries to improvise, and we'll see the last one. This is one of the images that it was finally able to draw. Some sunset, something about the garden, and it made a certain composition. So this is what the final image was look like. It looks very pretty, but only if you zoom in, you will realize that there are some very minor details which are not very clear. It makes a semantic composition, but it is not able to make sometimes the highest quality, finer details. I apologize, I was not able to run it with many other prompts, but if you are, feel free to. It's a lot of fun to see a lot of arts that you can do with it. And I'm trying to go back to my slides. Oh, wow, it crashed. It really crashed. Wow.
Did it crash because we're all using the Collab notebooks, trying to run our own models?
No, my iPad crashed. But I hope people who are using, they're having fun. It's actually a lot of fun. Okay, I'll try to go back to where I was. Okay, so we were at the VQ GAN clip demo, which we just saw. Next, again, this is a little technical. So again, who are experts, take a break and come back. We keep talking about GANs and see these very, very beautiful images. But there are certain issues to these generative adversarial networks. And one big issue is, what if either of those sub model become too good? That is, the goal of this, a little recap, the goal of discriminator was to successfully identify that real or fake. And the generator was to keep generating fake samples. What if discriminator becomes too good at telling that, okay, this is, and it always knows what is real and what is fake, so it is never giving enough feedback back to the generator to generate better fake samples. And what if the generator gets too good? This means, imagine during the model, the generator finds that one single image, which it knows that the discriminator will never be able to identify as real, as fake. I will repeat. What if the generator generates a fake image, but it knows that this particular image discriminator will always think that it is real. It will never know it is fake. Might do for others, but for not this one certain image. So the generator is getting too good that it is able to fool the discriminator. In both cases, we are losing the major purpose of it. There's not going enough feedback to improve either the discriminator or the generator. This is sometimes we also call, in this case, so Sasha Kotyar said it's a local optimum. We can say it's a local optimum, which is, I don't know if it's always the local optimum, but it definitely is. The model is failing to converge at some point of time. This is a little technical term for a general audience, but in an intuitive way, we can always say that model is collapsing. It is not doing what it's supposed to do. And this becomes an issue because the game is one-sided. You don't know when to stop because one of them has become too good. So as people were thinking about these issues and how to go beyond those tricks you use in machine learning, and especially in GANs, to generate these beautiful images, there came another wave of research, which was called diffusion model. Recall that we are still talking about 21 and 22. It is just like VQ GAN plus CLIP came out in 22. Diffusion models also came out in, they started way before. These are not new models, but they became popularized because of the issues people were facing in GANs, and they decided to explore this diffusion model. Now, this slide is not too technical again, but still, it would be good to know what I'm talking about. So diffusion model are types of, again, a generative model, but they're slightly different from how GANs work. In GANs, we had a discriminator, which differentiates real or fake, and a generator, which always generates fake. In diffusion models, what we do is we take an image and add noise to it, but only iteratively. You add small noise and then a small noise and keep adding noise such that at one point of time, the computer or you only see it as pure noise iteratively. This is called forward pass because you're trying to destroy the training data. Sorry, it's not called forward pass but it's just a process called forward pass. You're destroying the training data just by iteratively adding noise. And the second part to it, which is called a reverse process. In the reverse process, you're trying to reconstruct an image by decorrupting the noise iteratively. So you add that noise sample at one step, see what the output you get, again enter it back, and using some feedback. We cannot go in the details of the feedback because that will be whole another talk, but let's assume there is some feedback and it generates another set of output. It sees it. Now it uses that output and tries to compare with the original, original input, and again tries to remove the noise and reconstruct the image. It keeps happening iteratively, such and such that at the last stage, it tries to come up with a very fine image, which may or may not look like the original one, but it is still very high in diversity, and it does not face the problem of the convergence, which the GANs or the model collapse, which GANs were facing, because there is no generator or discriminators. It is not trying, one is not trying to fool the other, but one is trying to help the other. This was a very rough idea how diffusion models work. And using the idea of diffusion models, two ideas, two projects came out. One was from OpenAI and one was from Google. And they came around the same time. I think Imagen came in April and DALL-E in May in the year 2022, early this year. What was new in these models? They were using CLIP, that is the language features, these linguistic capabilities with the diffusion models. And to try to see that, we know that they already know that diffusion models help in creating good images, and they had some research to fall back on. They attempted to use the language with it. How language will work with diffusion models? Think it like this. Now you have a language, you pass it through some model and get some embedding. There's some knowledge about what that language looks like in vector forms. Yeah, okay. And now those language in CLIP, you can always try to identify what objects they might be associated with, because you've already learned from a corpus of internet. There are a bunch of images and there are a bunch of texts. And you use that gist of image and try to see, okay, give it a diffusion model and say, can you come up with an actual real image or whatever, or not real, but a realistic image. So they use the linguistic feature of CLIP, the diffusion models, that's the reconstructing of the reconstruction of an image to come up with beautiful images. The only way Imagen and DALL-E were different is DALL-E did all their training from scratch, a major part of the training from scratch. And Imagen and Google, they thought, well, we don't want to do from scratch. I think we already have some really good pre-trained models out there. Just use one of them and build upon it. So they were slightly different in this concept, but both of them have shown amazing, beautiful results. So you can see on of our DALL-E, it was a bowl of soup. That is a portal to another dimension of digital art. This was literally a prompt given, and the image was generated by the system. And the second one, it was 3 spheres made of glass falling into an ocean. Water is splashing, sun is setting. Given a prompt, and it generated this, this image. Both DALL-E 2 and Imagen became really, really popular because of how realistic their images were. In case of DALL-E 2, maybe some of you already have access to DALL-E 2 via their waitlist, but you can always create an account with OpenAI and play around with these prompts. You have there's certain limits like how many prompts you can use, but you can still use it. The issue between DALL-E 2 and Imagen was that both of them did not give their code available out to the public. One of the big thing about research is if you're bringing out a very cool research, it is helpful when people can actually use it. And the amount of compute OpenAI and Google has, a common person does not have, or even a big research lab don't have access to that level of compute, academic research labs, which led to a bunch of discussions and talks in the community that how can they use these models? Is there a way to reproduce this, or they were replicated? And there was this guy, I'm so sorry I forgot his name. He had a bunch of money. He said, I'll give you the money, I'll give you the compute, go and reproduce and replicate it. And because of this came Stability AI, which is the goal of Stability AI is they're trying to democratize a diffusion model. They funded this, they funded the diffusion model and made it open source. A bunch of people contributed to it, and the results that you got from diffusion models from Stability AI were actually very close to what Imagen and DALL-E did. And their code is also available to public. If you just Google diffusion model Stability AI GitHub, you will find their GitHub page. It starts with something called comp quiz. Can you use it? Yes, anybody and everybody can use it. There is no license. You can use it, I think, for both commercial and non-commercial purposes, but you might have to check it out. And this is an ongoing progress as they're diversifying and trying to make their models even better and better. We will play with Stability AI Dream Studio. I had beta access to it, and I think anybody can access to it, but we will come to it later. We'll try to do this at the last. I will ask people to give me certain prompts on Slack or chat. I will use those prompts on the beta on the Dream Studio, and we can see what those arts look like. How can you be a part of it? One is you can play with the model yourself and try to identify the kind of biases it might have, or how is it might be too good for something and too bad for something. So DALL-E 2 is available for use. You will have to sign up on OpenAI, create an account. Dream Studio is available for use. It also has an API, which you can probably make projects on and make it available to others. Stability AI Diffusion Model is also available in Hugging Face. For those who know, Hugging Face is a platform where it is again one of the platforms whose goal is to democratize how you can use the models. Anybody and everybody should be able to use models without knowing a lot of technical details. It's like a platform. You just should know the input. The model already is available out there, and you just see the outputs. How can you be part of the community building? So LAION or LION is a community of people who are actually actively building or evolving the data set that is part of diffusion models. They have a Discord channel. It's very, very active. You can probably just be a listener, and if you feel like later on you would contribute, you can always contribute to that community. They're very, very welcoming people. You can use any of these codes and some of the APIs that are available and create your own projects and share with people. Like art is something which is very, very cool to use anytime. Before I go to, if we start playing with stability.ai, here are all the references that I have mentioned, maybe a bit more extra at some places. I have put my slides on GitHub. So right after this call, the slides, you can just check it out, check all these references, and you should be able to play around and read more about any of the concepts that I have touched base upon. With this, I will move to stability.ai, but do we have any questions that we want to take before we start playing?
Yeah, feel free to pipe in and ask any questions you like.
I'm seeing on Slack a bunch of people are posting some beautiful photographs, and they look really, really nice.
Yeah, those are cool.
So
Okay.
when you were discussing kind of the stable diffusion.
Okay.
So would it be understanding the adding and removing noise process, like when in a crime show they're adding, they keep saying like computer enhance, like on a blurry security video. Like if it gets a face out of it, it's not necessarily the actual face, obviously.
No.
It would
It is
enhance.
it is some perturbation of a face. In fact, in case of especially stability.ai, they have put zero censorship. So there are places where you can see that how bad some of the possible facial reconstructions are.
Oh, a lot of the facial reconstructions are terrible. Yeah, I know.
Yes.
But
This is what they are trying to improve upon, and it's one of the weaker points also, that it does not know that difference very clearly.
right, so it's reconstructing what it thinks a face looks like.
It thinks of faces. Yes, it has seen a bunch of faces and trying to play the god's role here.
Okay.
Okay. I don't see any other question, neither on Slack, neither on the chat on Zoom. So let's go to the Dream Studio. You can always sign up for Stability.ai Dream Studio. Oh, actually, okay. Now let me share my screen. Give me 2 seconds before I go back to Stability.ai. Okay. Can you see my screen?
Yep,
you do.
can see it.
Okay.
The
For
dream
this thing, yeah. Okay. For this thing, I think I would like to probably go doing more interactive. This is what this Dream Studio looks like. How do you? So what you can do is we can just go to. I have to just a second. I have to share my whole screen to see what I'm showing. Okay, so you go to Stability AI, and as soon as you go to Stability AI, you'll see this beautiful page they have made. Scroll to the down here, you will see LAIO and the Lion. It's a community who's making these, at least for diffusion model, they have been doing a very good work. If you scroll even down, you will see something called Dream Studio. You can click on the beta access, and I think most people have got them. So we should be pretty much able to get the access. You can just sign up and request for it. I have the access for now. This is what it looks like. So you can change the height and width of the images. How much iterations do you want on the right-hand side? The model that they are using, the latest one is V1.5. Yes, so is there anybody who wants to give me a prompt? I just copy it from Zoom as you do it. Just me, I forgot the bit.
Who's got a good prompt? It's gonna be somebody other than me. I've been playing with it, and my prompt making skills are not great so far.
Okay, anybody else who wants to give me a prompt?
Let's see. There's a couple people typing in Slack. We'll see.
Oh, let me see. Okay, I think they're still typing. Okay, Sasha said, okay, V1.4 is released for public to download, and V1.5 is not. Okay, I'll use both Bart and James. Bart says a cat playing in a glass or orange juice. Let's see. So this cat playing in a glass or orange juice. I don't know what it will look like. Let's see. It looks like playing with the glass, and maybe near a glass, but it's not playing in a glass. Actually, since we're here, let me also try this. I also have DALL-E access. You can just try it on DALL-E. I think you guys can see my screen. I don't have many credits remaining, but let's see what DALL-E gives. DALL-E 2, actually. This takes a while to generate. So I will just use IndyPy participant generating discussion. Okay. Okay, so we have a cat playing in a glass. Or, oh, this is much more closer. Probably just dipping its toes into the glass. But again, we don't have the DALL-E open source. So the Stability AI is probably the closest we have of what we can understand how it works. This looks cooler. Now let's go back to the other one. IndyPy participants enjoying a speaker discussing AI generated art. Let's see what it thinks IndyPy participants do. So it's a bunch of people, and you can see how badly the faces are constructed, at least the ones who you see in front. But something's happening. It looks like a speaking session happening.
I'm amazed how close I got.
Yeah. Now let's do it in DALL-E 2. Okay. I can't be slag, but are there any more prompts that people want me to play with, or 2 are good enough? Okay, so this is DALL-E 2. Okay, faces are really bad in many of those reconstructions, but we can see most of them. I think it understands what it looks like to be in a speaking session. And it just morphs many of these faces. You can see here.
And the one on the far right almost looks like back in the good old days of being in the speakeasy. It was very much that.
Oh, sorry. I was just trying to see if you can make a variation of the image.
But it could be just me projecting onto the image like what I want to see too.
So it just makes a variation of the same image with different colors or something. And some of them look like ghosts. Okay, so these were 2 prompts. Are there any more prompts? Let me see. Yeah, I agree. DALL-E 2 was trained. I think it has a very good collection of stock photographs. Srishti, you can change number of image sliders to generate 4 at a time to make it more similar to DALL-E purpose. Oh, this is Dream Studio. Oh, I might not have seen it. Oh, yeah, I could have generated just 4 of them together. Yeah, by the time it is generating, we'll take more. A watercolor Python in the style of Monet. I love this thing. I was playing around with Monet styles. I think it got pretty close. I did a little something else, like a sunset and a garden and a bridge. I think this is pretty nice. Let's see what DALL-E does. Unfortunately, this is my last DALL-E prompt because I only have limited credits for this month. Okay,
That's cool.
this is pretty cool actually.
I just posted one I created on DALL-E. Posted a link to it.
Okay.
I'm pretty sure that's you, Felix.
No, I posted a Python snake and a Python program with discuss code written on a blackboard.
Wow, that was very specific.
Yeah, so actually I posted it on the Zoom chat.
In the Slack chat, because that's where it'll persist.
Oh, Slack chat. Okay, which one? The
IndyPy.
IndyPy.
Yeah, IndyPy.org general.
I can pull up and for everybody the link that he posted. Oh wow. Nice. Okay, so this looks like we don't have any more questions. So this was the end of my talk. I hope you guys liked it. I tried to make it a bit interactive along the way.
Yeah, any more questions for Srishti while we've got her here? This has been wonderful. It's really fun. It's just the things that people create with it. So we kind of touched on it a little bit, that some of these are going up for sale. People are generating them and selling them. But I think there's been some copyright issues come to the courts about that, right?
I've heard about it, yes. Yeah. I would never spend £22,000 for a digital art, but maybe someone has a lot of money and even willing to fight for copyright issues.
Yeah. So David still asking the question of, are these generated images really art, and does it have artistic value? I assume if you came up with the most amazing prompt in the world and it generated the most amazing piece of art that you thought was just beautiful and someone else did too, and they wanted to buy it, then it's art.
I can tell you one thing. My father is a lawyer, so I got some of that in my blood. Turns out nothing that is not made by a human can be copyrighted or can be, can I ask a trademark for it? And it happened because a monkey took a selfie of himself. Once it happened, a monkey got a camera and took a picture of himself. And the photographer tried to trademark the image, and the courts decided that the image was taken by the monkey, and as the monkey doesn't have agency, it's not a person, the image was not able to be trademarked or copyrighted. So I guess that applies for a computer too. You cannot trademark an image made by something that is not human, at least currently. Yeah, that's the selfie, right?
Yeah,
Thank you, Mario.
yeah.
So it's interesting in a legal standpoint, the fact that these generated images not made by a human, I guess, cannot be trademarked or copyrighted. But and this is my question. As I understand it, the art is somehow an expression of a person. It has an artistic value. So this generated art that doesn't have that person behind them, is it really art?
Personally, as somebody who paints, I think there's a little bit of crude, and a human made painting is a little more crude. You see those finer things in those paintings. I personally still value it. I think digital art probably has a lot of it might have a lot of value in spaces like advertisements or like digital media, where you might be able to catch audience attentions with those high resolution, very catchy images. When it comes to like human art, I would say, personally, I still value when people make those beautiful images. You get to see those interpretations, that a lot of interpretations you make in an art evolve as you paint. A single prompt might not be able to capture that whole sentiment of painting it for 2-3 hours. So probably we'll see how, if I mean, Monet, if it made a painting of the inspiration of Monet, which looked nice, but I don't know if Monet would still make the painting, would it still look like this or not? One of those questions.
That's awesome. Any more comments or questions? Yeah, I had read about the monkey selfie. There's a good Wikipedia page about it a while back. I think maybe.
Oh yeah, now I remember. Yeah.
Yeah, I think actually maybe like This American Life may have like covered it in one of their like segments, or some podcast I was listening to mentioned it. I went down the rabbit hole reading about it. But the case went on for a long, long time too. Pretty crazy stuff. That's really cool. So Matt says, what if a monkey creates a machine learning algorithm that in turn generates art? The permutations are endless, I think, on this. Cool. Well, then again, huge round of applause. Thank you, Srishti, for being with us this evening at IndyPy. I love the fact that we are still doing some virtual events, and we still have speakers coming to us from all around the world, and our attendees coming from all around the world too. We really appreciate you all being here.